Hey, it's Alex Williams of the News Stack here at DockerCon with the folks from Apcera here with Wally and Brian. Hey guys, how are you?
It's going great, yeah. Excellent time at DockerCon.
Day 2.
Having a good time?
Yeah.
Good. So, we're going to look at NATS, correct?
Yeah.
And so we're going to do a few things. We're going to give just an overview of NATS.
Mm-hmm.
You're going to show us how it works. And then you're going to do a use case, correct?
Yeah.
Great, well let's get started.
Excellent. So while I'll let you introduce yourself and then I'll give some context on that.
So I want to say I'm Wally. I'm part of this software engineer at Apcera. I do development of the Apcera Trusted Platform, but I also I'm maintainer of a couple of the clients from NATS, like such as the Ruby client, Python 3, Python 2 clients.
Excellent. So I'm Brian Flannery. I'm the community manager for NATS. So go to work a lot on technical blogging, meetups, talking to developers all over the place about how they're using NATS, and we'll have some specific information related to Docker, and Wally will show some of that. But just some foundational information on NATS for people that might not be familiar with it. It's an open source messaging system. It was created about 6 years ago by Derek Collison, who's also the founder and CEO of Apcera. Sort of the core principle behind that and why it was created in the first place is all around simplicity and performance. So, Derek, of course, has spent decades, whether it was at TIBCO or Google or VMware, working with large-scale distributed systems. And a few of the kind of mega trends that are going on right now, whether it's microservices or Internet of Things, or a variety of other ones, have sort of changed the requirements and sort of what people are looking for in a messaging system. Right now it's really going through a renaissance, the messaging space in general, and NATS is sort of at the forefront of that. So, NATS is incredibly simple. People, developers want a system they can just set up in a matter of minutes, literally. And so it's a Plaintext Protocol. It doesn't make any assumptions about what your infrastructure should look like. You can kind of just slide NATS in there and it just works. It's always available, so NATS is designed to always provide you essentially a dial tone when your systems are ready to communicate with each other, regardless of the scale that you throttle your infrastructure up to. It's just a few megabytes. It's incredibly lightweight. And then from a performance standpoint, if you look at some of the benchmarking compared to some of the other messaging systems out there, order of magnitude faster than most messaging systems, and that, as I said, remarkably simple. Some of the use cases we're seeing are things like microservices. Communication is a big one. So, a lot of developers right now, obviously, and especially with Docker, are looking at, how do we decouple systems into, multiple services and allow them to scale and communicate in real time. Of course, anyone sticking something in a container wants it to be very lightweight, very fast. That's the whole point in the first place of the container. So NATS is an excellent fit there. We're seeing a lot of adoption in IoT messaging as well, just because of the security and the performance around NATS. A lot of these devices don't have, from a hardware standpoint, are pretty simple, basic devices. So you really don't want to try and stick a heavyweight messaging protocol on top of that. So that's just some of the basic information about what NATS is, how it's being used, a couple of some of the use cases around IoT and microservices, and certainly we can jump a lot more into, as it relates to Docker, what we're seeing as well and how it's being used. The Docker image is available. It's an official image on Docker Hub. It's got over 1 million pulls at this point, so it's very popular and pretty widely adopted by Docker developers.
Great, well, why don't we take a look, see how it works?
Yeah, so I'll be covering first a little bit of the Plaintext Protocol from NATS. So as Brian mentioned, NATS itself doesn't try to get in your way, so it tries to do things as simple as possible. So it's a Plaintext Protocol, and it's actually pretty straightforward to type it out in the terminal. So here's an example. I just have couple of basic clients, and I will just do a basic pub subbing messaging, which is like NATS is optimized to do.
And PubSub is a very glassful to what's behind it.
That is correct, and I should have mentioned that briefly when I was giving an overview. But yeah, it's publish subscribe. It's traditionally a pure play publish subscribe messaging system. We have a release coming later this week that will provide things like persistence and messaging.
Yeah, so I have here a couple of clients plugged into the latest version of NATS. So it has all the latest and greatest features from master. And yeah, I mean, I bumped the authorization timeout so that it doesn't disconnect me, but so yeah, at its core is pops up messaging, so I can create a subscription to express interest in this below topic. I need to give it an ID for each one of the subscriptions I create.
So you could create multiple subscriptions to notify you really of anything that's happening, for instance, in your microservices platform.
Yeah.
So if there's an event, you could use NATS to provide a message about what just happened.
Absolutely, yeah. That whole event-driven space is a very good use case for that.
Yeah. So the Plaintext Protocol is probably one of my favorite things about NATS. It makes it incredibly easy to debug. It is how the traffic and how the communication is happening inside a distributed system. And so here you see them have expressed interest in these two clients on the hello subject, but you can use wildcards to express interest in the whole and any topic that is of anything that becomes published into NATS. So I can use the full wildcard for this. Okay, so if I send a message on the hello subject with 5 bytes, hello payload being world, then you can see that I'm receiving one message in this client. I'm getting a ping from the server because it is also built in a keep alive mechanism, so that you can also guarantee to always have an established connection to the server.
Okay.
So the server really optimizes to it protects itself from any unhealthy actor that you may have in your distributed system, so that those trying to make the request responses don't become affected by these other bad players inside of the system, right? So
because there's so many events, we really need that.
Exactly. And the other thing is, there's a lot of traditional messaging systems that try and protect the server, the subscribers, but if the server crashes, the whole system will go down. So NATS is sort of saying, let's make sure the server's always there.
Yeah.
You always have that dial tone, which developers really like when they're building distributed systems.
So yeah, so that's one of the things that also NATS gives you. You can, by using the NATS-based architecture, you can always guarantee to have at least established connection, meaning that you don't have to worry about creating for example, in case you're using HTTP request, then you need to open the socket and establish a connection to the server and send the headers and the payload, and then you have to worry about really wrapping all that stuff and then whether you actually close all that stuff and are you doing the garbage collection there. With NATS, you're just only focusing on doing the request and the response, and that's it.
Right. Classic.
So yeah, this is the basic protocol, and
so underlying architecture is PubSub, but what else is it? What else would define the architecture for NATS?
Well, the nice thing is the simplicity. Really, it doesn't really assume much at all. To be honest with you, it's essentially you have the server that's written in Go. And Wally mentioned some of the garbage collection and other things. We like a lot of the aspects of Go, especially the simplicity. Much like NATS, you can essentially look at the code and more or less read it. But yeah, it's that simple. Just the server, and then depending on what frameworks you're working with, and we have dozens of client libraries. Some from the community, people Arduino, or we maintain things like Node.js and Go and Ruby, but there's a variety of other, Rust and other things from the community as well. So you really pick your flavor.
That's the power.
Yeah.
Yeah. And now, since we're in DockerCon, I was thinking about giving an example of actually using NATS, the NATS Docker image. The 3 megabytes Docker image, very lightweight. Using Docker Compose to create a sample architecture of how that system using NATS looks like. Here is an example of how the architecture looks. So you have for external traffic, you can have a server receiving HTTP request, and you can talk to it for your Google Chrome or any web browser. in this system you have anything, all of the clients plugged into NATS, and besides externally you can have the HTTP request happen to this endpoint, but internally you can achieve low latency communication through the distributed system by using NATS.
Okay.
So this is how it looks like, a super simple use case.
Very simple.
Yeah. And so let me shut this one down. So yeah, I'm using Docker Compose to building the previous architecture that I was showing. There's a blog post along these lines of what we're showing here. So yeah, here we have the server that you can send HTTP requests against, and it basically has an endpoint that will communicate to one of the workers and make a request to expecting a single response. And so you can see the client is like less than 100 lines. I mean, the server, this example. We're establishing a connection to NATS here. Whenever you get a request on this handler, it is going to send a request on the tasks topic with a payload of help list, and then it is expecting at most a 5 seconds timeout. So this is analogous for when you're doing a HTTP-based communication of sending a request, and if you don't get a request by a certain time, then you're either getting a client-side timeout from your client, or if you're doing something like Nginx in the middle, a reverse proxy, which translates into a 504 like gateway timeout. So that's how.
So that's the basis behind the 5 second.
Yeah. So that's the thing with NATS. You can send a message, but there's no guarantee that someone will reply to that message, right? So you have to build this logic into the clients to either retry or short circuit into a different kind of logic.
I see.
Yeah. So I will build this example. Well, it's already built.
So it allows you to have the flexibility with the logic.
Right,
really
keeps it really lightweight, and as I said, we have some things coming later this week around persistence, but the way that it's designing, it's not getting baked into the server itself, keeping that just as simple as it is, and that would be done as sort of a separate layer.
Yeah. So here I just did Docker Compose up for this example, and then I can make a request to the NATS host. The port 8080. You can see that this is the trace. These are the trace logs from the server. You can see all the traffic happening in real time. So you can see that the server communicates to one of the workers and unsubscribe after a single response. And receive the message in less than 8 milliseconds. And so yeah, sometimes you can get like sub-milliseconds latency, right? So.
Yeah, and that's also, of course, really important when you're building large-scale distributed systems. Microservices, IoT messaging, people don't want to have a latency profile.
So here is a little bit slow because I have the tracing enabled for the server. If I turn off the tracing, then we will get faster actually replies because it is working on logging all this stuff. So yeah, one of the recommendations when using NATS is definitely not enabling tracing on production. Yeah, because that affects the performance a lot. Yeah. So yeah, it's a simple example.
How does this compare to other approaches for messaging environments within microservices and IoT platform services?
Yeah, generally speaking, I think NATS you find is much simpler, and it's really, again, it keeps coming back to simplicity and performance. There's other, there might be other messaging protocols that people focus on for, IoT as well. But these are a bit more dated and almost sort of a standard, so they make a bit of an assumption about what your architecture should look like. NATS strictly views itself as I'm there to handle the publish subscribe and always be available and do it in a way that's minimal footprint. So that's a big difference, I would say, is just the flexibility in comparison to some of the other houses.
Okay.
So I have a monitoring tool where you can also see the traffic that's happening here. So yeah, here you can see that in the Docker Compose example, you have two clients. So this is pulling data from the monitoring port from the NATS server, and then the client, the API, the worker server. So it always does accounting of the latest stats of the communication that happened in the server. So far we have sent 36 messages, and we only have two clients. We can use Docker Compose to scale up the setup a little bit.
Okay.
So yeah, now you can see that any client, Docker up, D, then scale the workers to 5. So here, I have 5 clients, and
Okay.
right now,
Now you can get that comparison.
Right.
So now if I make a couple of requests, you see that the same message is being sent to each one of the workers. So that's why each one of them have 6
right.
messages. And I can modify the client so that this becomes a distributed group. So that each one of the workers, only one of the workers receive a single request at a time, right? So this makes kind of like load balances the work between each one of the workers. We call this by the APIs of the. We can use this by the API of queue subscriptions. Yeah. So in NATS, it is really all pops up, but you also have like a very basic minimal feature set to. Which does help, like, to making the system more resilient. So here you have a group, and I'm going to stop this.
So what are some of the more interesting kind of examples you're seeing from the use of NATS?
Yeah, it's sort of, because it is so flexible, they're kind of really varied, but some of the more interesting ones I'd say as I've gotten to meet some of the developers and hear about some of the use cases. A company called NextGen Leads out of San Diego, and there's a blog post on our blog diving into that, but they're using NATS as sort of the glue for all of their microservices. They've got dozens of microservices that communicate via NATS, and they've been using that for about almost close to a year. There was a really good blog post on a company called GretaScript that went through in great detail sort of the 3 or 4, well, yeah, now they're on the 3rd iteration, going to their 4th of what their infrastructure looks like as sort of a next generation CDN. And they're using it as a signaling system. Some of the larger use cases are things like, it is a messaging layer inside Cloud Foundry. We use it inside Apcera. Companies like Baidu and HTC are using NATS as well. Ericsson, Siemens. I mean, there's quite a few large-scale enterprise use cases as well. Certainly, companies that are looking to sort of shift away from some of the complexity associated with traditional messaging systems and more into a distributed infrastructure approach are also looking at NATS, so it's pretty common there.
Yeah, so I just made the update, and you can see that only each one of the workers getting a request at a time. And
what's the difference in the messages here? Just number of messages that are coming back from the particular connection.
So so using this monitoring tool, you also have some basic sorting.
So obviously the API
is the one sending the most messages. Yeah. So the total of these should accumulate to the ones that the server is sending. So if there's time, we can show the latest features that authorization features that.
Let's take a look.
Okay, so until very recently, all of the subject namespaces in NATS were allowed to be published by any client. But now that authorization is built into the server, so to make a quick example, this. Okay. Can we look at this? So now you can determine users and which topics are clients to be able to publish messages. So, for example, here we have an example definition of a user that is able to publish messages in the help and the public subjects, and is able to receive requests through the inbox, which is the default inbox through which the clients use to be doing request responses. But by default, any user that plugs into NATS and does use their authentication credential like Susan Bass can only subscribe to public and cannot send any messages at all. So I can run the server using this mode. And let's see.
Yeah, and this just really lets you dial in essentially how who's seeing what messages is missing.
So you use NATS then to set up kind of communication between machines?
Yes, yeah, exactly.
So like if there's an event, then another machine can respond accordingly to what that event is? Right,
yeah, absolutely. And certainly in the Internet of Things space, although it's early, but that's an area where there's been a lot of interest around that as well.
So yeah, this is the hello world for authorization in NATS. This client using the Susan Bass credentials is not able to publish anything at all. It can subscribe, but if it tries to send any message at all, it will get a permission violation. So this just merged yesterday actually, so the latest build. Yeah, I think there's a lot of potential in this feature. Yeah, it's a game changer. It enables a lot of use cases for NATS. That's it for my endeavors.
Great.
Do you have any questions?
Well, I think, I can see how it's a use of the Internet of Things environment and in a microservices environment. And use cases that have, broad across the enterprise. I guess I was curious, where do you guys want to take this? Where do you want to go with it?
Yeah, great question. So this week we're actually releasing, as I said, sort of it's NATS streaming, so it's essentially adding a lot of the data streaming and semantics, big data semantics to NATS, ability to replay messages, persistence of data, zero subscribers, a lot of ways you think of sort of the core data streaming use cases, which we've heard a lot of interest in from the community. Ultimately, where we see NATS really fitting in is sort of the de facto control plane for how developers over the next few years will assemble and control their microservices, as well as Internet of Things. We've seen a lot of companies starting to show interest in using NATS as essentially a central event hub for the Internet of Things architecture that they're building, and that's a great use case as well, because you need to make sure that hub is always there, that it's incredibly fast, because you don't know really what type of devices are going to be connecting to the network, what their capabilities and requirements are going to be from a hardware, from a software standpoint, because NATS doesn't make any assumptions about what that looks like. It's really, I think we're really excited about where we're going with Internet of Things messaging as well.
So it seems like it's a core component of a communications network for distributed systems environments, such as microservices or
Absolutely, great way to put it. And we talk a lot, on our team, and as we're talking to developers, a lot about, this concept of event enablement of everything. So ultimately, down the road, NATS handling all of the, edge device communication.
It's a core philosophy.
Yeah. So it's been a great journey so far, and as you said, between some of the things that just popped in last night, so you've actually seen the first demo of that, and where we're going with some of the streaming capabilities. We're really excited about the next few years.
Well, Wally and Brian, thank you guys very much for taking the time to show it and helping me explain what NATS is, and we look forward to following its progress and this whole idea of these communication network across distributed systems in this event-based world. So thank you very much.
Thank you. Thank you.